All right, similar figures. So this video will kind of review on how to find missing sides of similar figures. You can find missing angles of similar figures and how just to tell when you have similar figures. So the definition of similar figures, and I'm just going to paraphrase here, means that you have the same shape, but typically you're going to see it as a different or with different size. Okay? If they have the same shape and the same size, then they would be congruent figures, which you could also say is similar. But similar figures, same shape, and they may or may not have a different size. So what we're really going to see this year, most of them are going to have different sizes. So I have an example right here. I think we can all agree those are the same shape. They are right triangles. If you look at it, think of it as I almost took this shape and enlarged it or blew it up to this size. Or I could reduce this shape down to this size, but it's the same shape. A lot of times I like to think of it as if you take a picture on your computer, and you know how if you don't click the corner of that picture, sometimes it won't be proportional, so your face might get squished together. When you enlarge a picture, you want to drag the corner of that picture on the computer. So the picture looks the same, right? If it's a picture with you and your friends, you all look the same. It just might be a bigger picture or a smaller picture. But it's the same shapes, just different size. All right? So a common thing that we hear in similar figures are corresponding sides or parts. So if you look here, it's really simple in this picture. I'm going to highlight those in orange. Those are corresponding sides. And those two sides are corresponding. And obviously these sides as well are corresponding. They're in the same position, if you think of it that way. I'll show you some examples where it might be a little more complicated to see of what corresponds with what. But this is a good way just to kind of recap that vocabulary that we learned. You can also talk about corresponding angles, just like we talk about corresponding sides. So if I have this angle, is going to correspond with that angle. If I put letters here to make it easier to talk about, so if I have, let's say, triangle ABC, and this is ABC, and I'll call it the image of ABC, you can see that A corresponds with the image of A, B corresponds with the image of B, and C corresponds with the image of C. So you can also look at it that way to see what is corresponding to what. Likewise, angle A corresponds like that. Okay? If you notice, the corresponding angles in similar figures are congruent. This 90 equals this 90. If I were to measure this with a protractor, these would be the same acute angle, and these would be the same. But notice the sides are not congruent. The sides are going to be...
Remember your package in the front office. We need to see Josh Morales in the front office.
The sides are going to be proportional. Okay? Things get a little bit more complicated when we see a shape like this. So when I see this, I still see similar figures. So they're just overlapping. So if you look here, you have the large triangle. So I have green and blue. I'll highlight that so you can see it. And then you have this smaller triangle that's kind of right on top of it. It's overlapping. So this side would correspond with it, and then this side corresponds with that blue. Okay? A lot of times, and I would highly recommend this, I would draw them separately, kind of like composite figures where you take the two shapes and separate them. So you can see you have this big triangle right here is similar to this little triangle right here. So I kind of slid this little rectangle or little triangle off so that you can see these sides still correspond, these sides still correspond. We can see that those corresponding sides are proportional, and I'll prove that in a second. And then the corresponding angles are all congruent. Okay? The other way you might see it, so here we saw them separate, here we saw them overlapped, but notice they're still kind of oriented in the same direction. Over here is another way you might see these shapes drawn, where it's rotated around. So if this was my original figure, you can see this little shape is kind of, if I were to rotate it around, this side would correspond with that, and this side would correspond with that side. So that one's a little more tricky to see. Again, I would recommend the same strategy of redrawing them. So you're kind of taking this and rotating it around so that they are oriented in the same direction, and it just becomes a lot easier to see with what corresponds with what. Okay? That is kind of the basics of what similar figures are. Two rules I've kind of said over and over again. Corresponding angles in similar figures are congruent. Corresponding sides are proportional. So the proportional piece of it is what we're really going to kind of focus on now, because if I know these sides are proportional, then I can solve for any missing side of similar figures in these situations. So that's what we're going to kind of do. I'm going to do this just on this basic picture, because again, no matter what picture I give you, you're going to want to redraw them so they look like this. So here where they were rotated, I redrew them so they're side by side, just like this. Once you get to this picture, no matter what the shape is, it's a rectangle, it's a heart, whatever it is, I'm using triangles just to kind of keep it simple. Then you can solve for missing sides or to see if they are proportional. Okay? So I'm going to set up a proportion. We know they are proportional. And let me just kind of put a disclaimer in here. There's lots of ways to set up this proportion. Okay? I'm going to show you one way. It will work every time. And then from there, I'll tell you how you can write other proportions. But rather than teach you 8 different ways of writing proportions here, this has always worked for me very well. I'm going to teach you one way to set it up. You set it up this way every time. And then once you have one proportion, I'll show you how you can write all the other proportions that will work. Okay? So let's pretend this is 5 feet. This is, we'll do 3 feet. I know it's not the scale. We're just going to do that. Let's say that this is 6 feet. I'm going to keep the numbers very friendly, and I want to know here. So to give you like a real world example, this might be the height of your dad. He's 5 feet tall, and he's casting a shadow that's 3 feet long. And if you are casting a shadow that is, you know what? Hold on. I want this one to be smaller. So let's try that again. Your dad is 5 feet tall. He's casting a shadow of 6 feet. You want to know how tall you are if you cast a shadow of 3 feet. Okay? And so we're going to figure this out. We know if these are similar figures, which I'm telling you they are. I want to find this missing side. I know the sides of similar figures are proportional, meaning the same ratio from 5 to 6 is the same as the ratio from x to 3. To show you how that looks in our proportion, I always think of this first ratio from the first shape or first figure, and the second ratio from my second figure. Okay? A lot of times you can even write this proportion right underneath the picture to help you set it up, which is what I'm going to do. This ratio goes with this shape. This ratio goes with this shape. And it doesn't matter if this is the bigger shape or the smaller shape or where x is. We just know they're proportional. That's how I'm going to set it up. Okay. First ratio from here, I'm going to say is 5 over 6. It doesn't really matter. If I put 6 over 5, that's fine. But, I mean, it makes logical sense for me to put 5 over 6. And I'm going to color code it. This is that orange side, and this is the blue side. Okay? If I look at my second figure then, I know it's going to go in the second ratio. So I have orange over blue over here. So I'm going to do orange over blue on my second ratio. So the orange side is x, the blue is 3. And that sets up my proportion. Okay? If you look at it, the 5 and the x correspond. Sometimes we see this symbol as corresponding. The 6 and the 3 correspond. Sometimes you see that symbol as corresponding. This is how you will see me setting up proportions all the time. Okay? From there, you can do cross products, or you might see a quicker way to change. You can say 6 divided by 3 gives you 3. So 5, or 6 divided by 2 gives you 3. Whoa. And then 5 divided by 2 will give you 2.5. Or you could do cross products, right? 5 times 3 is 15, divided by 6, and you will get the same answer. So every time when I set up proportions, I'm going to do the first ratio from the first shape, the second ratio from the second shape, and then I make sure this numerator corresponds with this numerator, this denominator, or second part of my ratio corresponds with this number. So these correspond across. All right. From there, I can write many different proportions. So if for some reason I ask you, well, which proportion is true, you know for a fact that 5 is diagonal from 3, or you'll hear me say across sometimes. 5 is across from 3, and 6 is across from x. So no matter what, if I were to write this proportion, is that correct? Well, no, because we know from here 5 needs to be diagonal from 3, and that is not true. That proportion is not correct. I could write the proportion like this. And I could ask you, is that correct? Well, yes. 5 is across from 3, and 6 is across from x. And so you can use, once you have one proportion, guys, you can use that to figure out, oh, does this proportion work? Well, it will if 5 is across from 3 and 6 is across from x. Okay? I'm going to do another example on here. I know I'm using triangles every time. Just know that this applies to any similar figures. Okay? I'm going to call this 5 and 10. We're going to put x down here this time. And I know I'm making these numbers very easy, and that's okay. So 5 units, 10 units, 10 over x. I would encourage you to pause the video and see if you can set up a proportion to solve for x. Okay, hopefully you already tried to set it up, so now I'm going to show you. This ratio I want from the first shape. I'm going to do 5 over 10. It just makes sense to me to put 5 and then 10. Whatever 5 corresponds with in the second shape, I'm going to put right there. So 5 corresponds with 10. 10 corresponds with x. And then I'm ready to solve it. Okay? There's lots of ways you can solve it. Cross products will always work. Or you might see, oh, 5 times 2 is 10. 10 times 2 will give you 20. All right? So whenever you have similar figures, just know corresponding sides are proportional. And so you can use a proportion to find missing sides.